I welcome you all in the technical session 5 of this international conference on recent trends in chemical research. So in this session, we will start with the talk from Dr. Sunil Kumar. Dr. Sunil Kumar is Assistant Professor in the Department of Chemistry in J.C. Bose University of Science and Technology, YMCA, Faridabad. He has teaching experience of around 7 years and postdoctoral experience of around 3 years. He has industrial research experience to his credit also. He has worked in Jubilant Organisms Limited, Noida for 2 years. He has various awards and fellowships to his credit, like he has been awarded CSIR Net Fellowship. He has been a project fellow in a UGC project. He has been a senior research fellow in a CSIR project. And he's a multi-cultural personality, you can say all-rounder personality. He has been very active in NCC. He has NCCC certificate. He has been a postdoctoral fellow in MOST Taiwan. He has been National Postdoc Fellow in a DST Serb India. Royal Society of Chemistry Best Poster Award also he has won. He is member of Indian Science Congress Association, Kolkata. He is member of Chandigarh Region Innovation and Knowledge Cluster, Chandigarh, also various research publications to his credit. So we hope we'll learn a lot from your talk. You have been delivering various invited talks in various conferences, and obviously these talks infuse new ideas in the minds of new researchers. So I welcome you, sir, and I request you to take over for your presentation, please. Dr. Sunil Kumar.
Thank you, Deepa. Thank you very much for my nice introduction, and good afternoon to all the participants present here. And so, for today, my topic of talk will be the research.
Sunil sir, sorry to interrupt you, but आपका volume थोड़ा कम है.
Okay, let me see. Is it audible now?
Yes, sir.
Okay. So, good afternoon to all of you. So, let me share my presentation here once. Is it visible, ma'am?
Yes.
And slides are moving or not? Can you tell me?
नजर आ रही है सर, आप फुल स्क्रीन कर सकते हैं, इनफेक्ट करना चाहें तो.
आप फुल स्क्रीन में मैम स्लाइड चेंज कर रहा हूँ, तो स्लाइड चेंज हो रही है आपकी साइड में? वही
नहीं, चेंज नहीं हुई सर.
ओके, देन
अब चेंज हुई है सर.
ओके, देन आई विल कीप दिस मोड. एक्चुअली फुल स्लाइड मोड विल बी सम प्रॉब्लमेटिक.
ऑल
थैंक यू मैम. So, dear participants, very good afternoon to all of you, and I thank to the organizer for giving me the chance to present my work here. Today I will present here research work, synthesis of nitrogen-containing 5-membered heterocyclic compounds. I will discuss 3 work here, one by one. First one is the diversity-oriented synthesis of coumarin-linked benzimidazole. In this work, I will talk about the synthetic chemistry mainly, so that all the synthetic chemists who work in this field can understand the topic easily, and whoever have any doubt or any question in between, you may ask in between. So, first one is the diversity-oriented synthesis of coumarin-linked benzimidazole. Various azoles are reported in the literature as they are present in the various medicinally active compounds, like thiobendazole is an antifungal agent. These benzopyrrole and oxazole derivative are the diamino oxidase inhibitors. Diamino oxidase is an enzyme which plays important role in our body. novobicin, which is the coumarin containing compound, act as antibiotic agent. So by seeing the literature importance of azole and coumarin, we have tried to synthesize a clubbed hetero. Further, this was reacted with the salicylaldehyde, which on cyclization give the intermediate 8, which was further converted into the desired heterocycle, coumarin-linked benzimidazole 6, in the presence of HD condition. Here, 8 act as the intermediate. We have also isolated this one and also characterized it with the help of X-ray spectroscopy, single crystal X-ray. So on the behalf of this, we can also propose its mechanisms that this reaction occur via this imine formation. So overall, we have firstly we carried out this synthesis step by step, and then we tried this in one-port synthesis. For this, we have taken these 2 aminophenyl cyanoacetic acid as the starting precursor, and in one port in single or round bottom flask, we have added these reagents one by one. Firstly, we added the paratoluene sulfonic acid and stir it for 4 hours. Then we added it in the same flask salicylaldehyde in the presence of triethylamine, and again stirred for 5 hours. And after noting the TLC, then again we add dilute HCl to the same flask. And finally, we take the workup of this crude product, and we get the 6 in single step. So we have carried out this one-port synthesis of 2-coumarenyl benzimidazole, and we have used this approach for various different amine, different R1 and R3 groups which are on the coumarin and this benzimidazole moiety. And we have, you can see in the picture, there are products which are like 87%, 88%, and various products are formed in this case. Further, we evaluated these compounds for the diamine oxidase inhibitory activity, and it was found that this compound number 6241, which contain the cyclopentyl ring connected with the amine, of the benzimidazole, and this was found to be the maximum inhibitory concentration, and it was just around 54 micromolar. So this work was published in the Advanced ACS Combinatorial Science. In my second project, is I audible to all of you clearly? Is I audible? Can someone reply?
Yes.
Okay, thank you, sir. So in this second work, various selenazole derivatives exist in the literature, which exhibit various types of activity, like selenazopurine, which is well-known antiviral drug. Amsilamine acts as histamine H2 agonist. Absilane is again an anti-inflammatory agent, and acylamidose selenazole is also an SOC channel regulator. And again, we can show many compounds which contain coumarin and are biologically active. So from these two privileged scaffolds, we try to combine them in a fused manner and propose the synthesis of isocoumarinosilenozoles. Retrosynthetic analysis of this isocoumarinosilenozoles give us two starting precursors. One is the alkyne, which may be commercially available, and another one is the benzoselenazole, 2-amino-benzoselenazole. 2-amino-benzoselenazole further can be synthesized using the isoselenocyanate and 4-fluoro-3-nitro-benzoic acid. So we have started the synthesis using this approach. Initially, this 4-fluoro-3-nitro-benzoic acid was methylated in the presence of sulfuric acid. Further, nitro group was reduced with the help of zinc and ammonium formate. Further, reaction of 2A with the isoselenocyanate was optimized in using different base and different solvent. And mainly it was found there was formation of three products. One is the desired 5A, that is our required 2-amino-benzoselenazole. Along with this, there is formation of selenourea and one unexpected product, that is the benzimidazole derivative 4A. So using the different base and solvent, we have tried to find the 5A in maximum yield, and it was like 45 to 55%, which we could achieve maximum. And in some cases, it also gone to the like 80%. For example, we can say we can see here like phenylpropylamine, in that it is 80%, and paramethyl benzyl, it is also 71%. So we prepared this starting precursor to aminobenzoylenazole in good yield using the optimization. In literature, there are various reports there. This moiety is synthesized using the metal catalyst. We have also avoided the use of metal catalyst in this reaction. Our next step was the alkylation of this 2 amino group, which is present in 5. During the alkylation, there are two chances that alkyl group may be go on the either on the 2 position, or it may also go on the nitrogen of the selenazole ring. So, so we have to achieve the synthesis of mainly during this reaction. There is formation of 6 and 7, and in major product was the although 6, but we cannot deny that there was also formation of 7. So we have to take both these derivative in the next step, and we try to carry out some chemistry from here. So in the table, we can see the substrate scope where various amine precursor are used, and alkyl bromide which are treated with this. Various alkyl bromide are used containing aromatic aliphatic substituent here. And from this table, we can see, one can see mainly that there is major formation of 6, and the formation of 7 was in very low amount. So structure of these isomeric compound was also analyzed with the help of a NOE experiment, in which we can detect the NOE correlation between the hydrogen present near to the 2 amino moiety and on the benzene ring. And structure were also characterized using the help of single crystal X-ray, and we were able to predict the structure of these compounds. Now, next main step is the reaction of alkyne with this synthesized precursor 2-amino-benzoylenazole. This reaction is also, when we tried this reaction, because this reaction involved the CH activation, that is fourth position hydrogen of benzoylenazole has to be activated so that alkyne can react here. And for this, we have tried the metal catalyst, rhodium catalyst, ruthenium catalyst, and we have also used some oxidant to enhance the speed of reaction, copper acetate or oxygen. And finally, it was found after the optimization that ruthenium catalyst, in the presence of oxygen as catalyst, molecular oxygen as oxidant, a reaction gave the regioselectivity toward the product 9A, which is the angular product that is formed by the cyclization of alkyne from the above side, and another one is the isomeric product is the 10A, which is called the linear isoselenazole, which we call here linear isocumarino-selenazole, and that is formed in the low amount. And so measure here it is 9A, and about 15% we obtained the formation of 10A. Again, their structure was also characterized using the NMR-IR data and single crystal X-ray structure. So using the same ruthenium catalyst and oxygen as oxidant, we have synthesized various type of isocumarino-selenazole here. And in this, 9 was obtained in major amount, whereas 10 is obtained in lower amount. And in the table, R1 and R2 shows the substrate scope here. So in this case, we can see like there is formation, major amount is angular isocumaranolazole and lower amount is linear isoselenazoles. So, but when further we tried the another isomer I can show from this last slide, there was formation of this compound number 7, which contain the R group at nitrogen. When the reaction of this compound was tried with alkynes, this shows the only formation of linear isocumaranoslenazole. So from this study, that in case of 10, where selenazole nitrogen was not alkylated, there was formation of angular product, and when N was alkylated, there was formation of linear product. So this shows that there is a role of this nitrogen in this reaction, which control the product formation. And the product of both these reactions were characterized using the single crystal X-ray crystal of both the compounds. And in this case, we have also, for the substrate scope, 5 compounds were synthesized, having the different substituent. So, as there was formation of 2 products, one was the angular. So, angular product was ported by the this ruthenium catalyzed CH activation was by saying that initially the nitrogen of selenazole form the complex with this ruthenium catalyst and then activate this hydrogen, nearby 4th position hydrogen, and give rise to formation of angular product. But if N is alkylated, then there is no scope of the formation of this ruthenium complex with this nitrogen. So the product will be the linear product. So in this case, when nitrogen is not alkylated, then we get the angular product. But if nitrogen of selenazole, nitrogen at 3 position of selenazole is alkylated, then we get only linear product. This work was published in the Advanced Synthesis and Catalysis. Now next is the synthesis of basalamide, a marine natural product, and its analogues and their biological evaluation. Basalamide is basically a thiazole containing tryptamide alkaloid, and it was isolated from the marine bacterium Bacillus species SY1 during termination of blooms of Coclodinium polycricoid by Jong and co-workers in 2003. Basalamide is also known as Basalamide A, which is shown by number 1 in structure here. It is the first compound which showed excellent algacidal activity against the harmful Coclodinium polycricoids, one of the most harmful dinoflagellate associated with the mass mortality of cultured fishes in Japanese and Korean waters. In 2007, Socha and co-worker have also isolated another analogues, Basalamide B, Basalamide C, Basalamide D, and then Neobasalamide A was also isolated from the Thermoactinomyces species strain TM64. Now, our main focus is the synthesis of Basalamide 1 to explore its further biological activity. In 2005, Figueria and co-workers developed the first and only synthesis of Basalamide. They have taken 4-methyl-thiazole as the starting material. 4-methyl-thiazole was acetylated at 2nd position. Further, it was brominated, and monobromo product was further reacted with the silver acetate to form the aldehyde, then converted to the acid, and which further on coupling with the pivalyl chloride in the presence of diisopropylethylamine gives this anhydride product, which on reaction with the tryptamine yield the Basalamide 1 along with an unexpected product. From this synthesis, the overall yield of the Basalamide was only 14%. So our aim was to improve the yield and use the same method for making the various analogues of Basalamide. Retrosynthetic analysis of basalamide gives us two starting material. One is the tryptamine and another one is the 2-acetyl 4-carboxythiazole. Tryptamine is commercial available, whereas 2-acetyl 4-carboxythiazole can be synthesized by the two route. One is the 4+1 approach, another one is the 3+2 approach. 4+1 shows the reaction of L-cysteine ethyl ester hydrochloride with the pyrrolidhyde. And another approach, if we want to adopt here, is the Hunt's-thiazole synthesis, that is 3+2, in which 3 heteroatom from the one substrate and 2 from the another one. So firstly, we try to synthesize this compound using the route A. For route A, we have explored the reaction of L-cysteine ethyl ester hydrochloride with the pyrrolidhyde, and in the presence of sodium bicarbonate and aqueous ethanol, it gives 2-acetyl 4-carboxythiazole in the 60%. Further, we coupled this product and tryptamine with the thiazole with the tryptamine, and after the optimization, we have found this 4,6-dimethyl hydroxypyrimidine as a solid phase catalyst. And this reaction was carried out without using any solvent. In this, we have mixed these 3 compounds, 14, 16, and 23, and heated them up to 90 to 95 degrees for 6 hours. After the workup of this reaction, we get the basalamide as the product of this reaction in about 55% yield. So proposed mechanism was also given for this reaction, in which we have shown that hydroxypyrimidine form a complex with this tryptamine and thiazole and give rise to this 6-membered complex, and then it may give rise to this amide bond formation, and final product is obtained. These are NMR peaks, which are shown here, the characteristic peak of this basalamide. We have also, this route is only used for the synthesis of basalamide 1, because we cannot explore synthesis of another thiols using the same method. So we have tried using this like ethyl. We have prepared alpha bromoethyl pyruvate from ethyl pyruvate and tried to react it with the thiamide, which was obtained from the pyrrolidhyde. But this reaction was not successful. So we used the route B for the synthesis of another derivative of this thiazole. We used simply the Hunt's-thiazole synthesis to prepare the 2-aminophenyl thiazole or 2-aryl thiazole, and after obtaining the synthesis of these thiazole, we coupled them with tryptamine, and we obtained 32, like here the scaffold 32, 7-8 substituent variation in this at the R position, and we have prepared these compounds and evaluated them for the biological activity. This was published in the European Journal of Medicinal Chemistry and Archivo. So in next work, I want to show the synthesis of some pyrazolyl thiazole. Again, we know the biological importance of azoles in the medicinal chemistry. There are various scaffolds which are available in the medicinal drugs, and another scaffold which are under the clinical trial or other have found to be exhibit the good activity. These are some of the examples. In case of these, in this we have this precursor is already reported in the literature 42, which is prepared by the reaction of trifluoromethyl beta diketone with the reaction of thiosamicarbazide. This pyrazolene was treated with the coumarenyl acetyl bromide, and we obtained the synthesis of 57. Further, 57 was dehydrated because we have to obtain the pyrazole here. So pyrazolene was dehydrated with the help of acetic anhydride, And we have optimized this reaction using the direct approach, that is from the cumulonyl bromide, using the ethanol and sodium carbonate, and we directly obtained the product 58 in this case, that is pyrazolyl thiazole. So again, we have used here substrate scope and synthesized 7-8 compound in this, and evaluated them for the biological activity like antimicrobial and anti-inflammatory. Some of compound exhibited very good activity, and this work is also published in the European Journal of Medicinal Chemistry. So this was all from my side. Hopefully you will get some, you will get the better understanding of the work which I shown you here. So thank you very much to all for your patience. If there is any query or question, I am here to solve.
Well, any questions from the audience? If any questions are there, you may come up, please. Otherwise, I would request Dr. Sunil to share his email ID in the message box, please. If anyone has any doubt, any query, or any offer to collaborate, you can always contact Dr. Sunil. Thank you, Dr. Sunil. Your work is really appreciable, commendable work you have done, and we wish you all the best in your research journey. And now I request Dr. Babita to take over the session, to chair the session, please. Dr. Babita has joined or not? May I know?
Yes, ma'am, I have joined.
Okay, I would like to introduce you to Dr. Babita. Thank you, Sunil sir. Thank you, Dr. Sunil. Yes, I would like to introduce Dr. Babita to the audience. Dr. Babita is Assistant Professor of English in our college. Very hardworking and very humble and extremely learned professor. So I would like Babita to take over, please. Dr. Babita, please.
Thank you, ma'am. First of all, a very good afternoon to all of you. And now I would like to introduce you with our next speaker, Dr. Deepa Sharma, Assistant Professor of Physics in the Department of Higher Education, Haryana. Dr. Deepa Sharma is a theoretical physicist with expertise in computational nanophysics, spanning across spectroscopy, optics, condensed matter physics, and electronics. Her research work is focused upon simulation and modeling of carbon nanomaterials and calculation of their electronic, spectroscopic, and optical properties based on density functional theory and tight binding model. Her recent theoretical prediction of the possibility of proximity induced superconductivity in single-walled carbon nanotubes has proven to be a path-breaking innovation, paving a novel research pathway for the experiments to explore. She completed her doctorate degree in physics from National Institute of Technology, Kurukshetra, India, and she is serving as an assistant professor Kurukshetra of physics in the Department of Higher Education, Haryana since 2006 and currently posted as head Department of Physics, Shahid Udham Singh Government College, Mahatmajri, Haryana. Her achievements, however, extend much beyond academics. She is currently the National Coordinator and Chairperson of the International Affairs Committee of Committee of Netball Federation of India. She is nominated as the Indian delegate to attend the AGM of Asian Netball Federation and International Netball Federation in 2020 as well as in 2021. Recently, she has been nominated as the Indian Olympic Association representative nominee for Khelo India Youth Games 2021, and she has been a recipient of Pride of India Award also. And with this short bio, I know ma'am has achieved much more than that. With this short bio, I would like to welcome Dr. Deepa Sharma for her presentation. I welcome you, ma'am.
Well, thank you, Dr. Babita, for the nice introduction. And I would request Dr. Sunil to kindly stop sharing so that I may share my screen. Dr. Sunil, kindly stop sharing. Is my screen visible to all? All right. So I am thankful to the organizers for providing me opportunity to share my work with all of you, all the researchers present here. As you see, boundaries are fading. So chemistry and physics, they are just like siblings. So most of the work in physics involves the knowledge of chemistry and inspires the chemistry research also. And most of the work in chemistry, in fact, provides ideas to physicists and leads on their research too. So my topic today is exploring the properties of single-walled carbon nanotubes using the simulation route. You see, as introduced by Dr. Babita, I am working under the aegis of Department of Higher Education, Government of Haryana, India. That is an umbrella institution which covers around 10 state universities, 170 government colleges, 24 private colleges, 2 government colleges of education, 86 self-financing degree colleges, 475 self-financing B.Ed colleges, and 97 government-aided private colleges. So we come under that umbrella and we are transferable over all the 170 government colleges. So our affiliation keeps changing. Regarding my work is associated with carbon nanotechnology. Carbon, is a very wonderful material. Since ages, it has been intriguing the scientists. It has been surprising the scientists with its properties. And that's why 3 very reputed prizes like 2010 Nobel Prize, 2008 Kavli Prize, and 1996 Nobel Prize. These are associated with various different allotropes of carbon only. Fullerene, then carbon nanotube, single-walled carbon nanotube, and then this graphene. All the 3 discoveries, they bagged these prestigious prizes. Diamond and graphite, of course, have been known since ages. There's graphene, single-walled carbon nanotube, and fullerene. These are new additions to the family, recent additions to the family, and they are many researchers are involved in research on these materials. Nano structures की अगर बात करें तो in nano structures carbon nanotubes they are formed by rolling the graphene sheet in the form of a cylinder, and according to whether that is single wall or we are using 2 walls of the cylinder or multi walls of the cylinders, there can be single walled carbon nanotubes, double walled carbon nanotubes, multi walled carbon nanotubes, and depending upon the orientation of the fold, we can categorize them as armchair, jig-jig, chiral, single walled carbon nanotubes. So they have very superior properties like about their mechanical strength. A single walled carbon nanotube of thickness of around equivalent to the thickness of a hair, that is more strong, that is stronger than a 10-meter wide steel rod. You can see how strong they are, their mechanical strength. Then their electrical properties, they can be conducting also, they can be semi-conducting also, and they can be insulating also. All depends upon the chirality of the nanotube. So that's why, because their electrical properties range over various conductivities values, various conductivity values, so we can use them across a various number of potential applications. Now, regarding my research, you see, earlier there were only two dimensions of research. Either it was an experimental research in sciences or it was theoretical research in sciences. But with the advent of computers and with the advent of IT technologies, a new dimension has been added to research, and that is simulation. In simulation work, we do experiments, but we do virtual experiments in a virtual environment. So supercomputer simulation have become very essential in making discoveries and advancing science nowadays. Regarding the computational tools, there are a number of computational tools available and that are being used by the researchers all over the world. And these computational tools can be categorized into like atomistic calculations they can make, or they can make calculations over a continuum. I have used the atomistic tools. So in atomistic tools also, there are two different kind of tools. Either we work with finite structures or we work with periodic structures. I have chosen the periodic structures. Then when we work on the periodic structures, we can use either classical methods or quantum mechanical methods. So I have gone for the quantum mechanical ones, and in quantum mechanical ones also, either we can choose to go with the semi-empirical methods or with the ab initio methods. Ab initio methods, they don't use any approximations, while semi-empirical methods, they use various approximations here and there. So I have used an ab initio method using density functional theory for my calculations. Now, to do these calculations, the software I have used is Material Studio. Material Studio software, I have taken this snapshot to make you familiarize with it. On the screen, you can see there is a builder over which we can use different atoms and use them to build up any structure we want to. Then we can run various tasks on those structures in a simulated virtual environment, and we can conduct virtual experiments on them. On the right hand side, bottom, you can see we see that job is running. You can see it is written starting. The job is starting now. So this window shows the progress of the job. Then on left hand side, there are various files and folders in which the results are stored. There are various properties that the software has calculated. So this is just to familiarize you with the software. So you can see another snapshot from my work in which I have simulated a single-walled carbon nanotube. You can see with the blue background. In purple color, this is 1 unit of a single-walled carbon nanotube, which when periodically repeated in all the 3 dimensions will create the entire single-walled carbon nanotube. So I have developed this structure using the builder function of this software, and then we can calculate various properties on it. The key factor is the parameters we use for calculations, which functional to choose, which sub-functional to choose, and whether we have to optimize geometry or not. All these things matter. How accurate our results will be. If we don't choose the parameters well, our results will not be accurate. So the process of molecular modeling, that involves first we build the model, then we refine the model, we refine, optimize, minimize with the chosen method, again minimize, use the dynamics, and if the refined model is not delivering good results, we again build the model and we again refine it. So there are sequences of refinement, and then the simulation algorithm that does the calculations, and we analyze the calculation of properties we do during the analysis process. So what we do, how to proceed? We define the topic first, then we define the question, then we choose the technique or model, and we make calculation. When we make the calculation, the important part is validation. Since we are working on an imaginary structure, so it is quite possible that structure may have some flaws, some empirical flaws, which may result into drastic results which can't be true. So we have to use experimental validation to verify those results also. So some validation part is very important. And if after the validation we are satisfied, we'll make more calculation and analyze the results. But if we are not satisfied at the validation stage, we'll have to modify our technique or we'll have to modify our model and we'll have to repeat the task again. This is how the model structure looks like. I have used the CASTEP module using the supercell approach of the Material Studio software. So you can see the supercell is created by the single walled carbon nanotube. We are not considering the isolated single walled carbon nanotube. Rather, we are considering a supercell created by the extension of single walled carbon nanotube in all the 3 dimensions. Now this is how we set up the task. We choose geometry optimization, then CASTEP calculations. We have different properties given. We choose which model we'll use, whether we'll use density functional theory or we'll use Hartree-Fock method or we'll use DFTB. That depends. That demands for a scientific intuition and that demands for experience. You must know which functional to use, which sub-functional to use, which method to use in what kind of task. That is the main thing to be decided during setting up the tasks. Now, these are the optimization convergence curves. The software optimizes the tasks, and during the optimization process, it chooses where the minimum possible force is acting on the atoms, where minimum possible energy the system is
Good evening, sir. Welcome, sir. Deepa ma'am.
Good afternoon, everybody.
Good afternoon, sir.
Good afternoon, everyone.
Good afternoon, sir.
Good afternoon.
Welcome, sir. Welcome, Sudhir, sir. Dr. Sudhir, I would like to let you know that this conference is going on for last 2 days. And very eminent speakers from all over the world have presented their research work on this platform. And we are headed towards the valedictory session of this conference. I would introduce the speakers of the session. Dr. Sudhir Kumar, to the audience. Dr. was born.
I'm not getting audio.
I'm sorry for the network issue. Dr. Sudhir Kumar was born and raised in holy city of Kurukshetra. He has earned his BSc and MSc from University Kurukshetra, and he worked as UGC JR with Professor H.K. Pujari for his PhD degree in synthetic organic chemistry from KU Kurukshetra only. After a short stint with the then Ranbaxy Laboratories, New Delhi, he joined CCS Haryana Agricultural University, Hisar, as assistant scientist in 1990. Kumar has been under the supervision of Dr. R.S. Verma. He was elevated to the post of associate professor and then professor. A chemist by training, Dr. Kumar was instrumental in starting the discipline of bioinformatics in the university in 2004 and continues to work in bioinformatics as well as chemistry. He has published 46 research papers in various peer-reviewed journals. He has been INSA visiting fellow and MHRD lead trainee. He has served at various administrative positions in his university and has been recipient of many professional fellowships, Boycast Fellow, INSA Visiting Fellow, in charge computer section. He has been head of bioinformatics section, advisor and president Mountaineering Club, advisor faculty and academic affairs. He has been vice chairman of campus school CCS HAU and has been the head of department of chemistry since 2019, lead trainee TISS, Mumbai and University of Pennsylvania, USA. So I welcome you, sir, and the floor is all yours. Thank you so much for joining us, for your precious time for us.
Thank you, Dr. Deepa.
Yes.
It's my privilege to be with you all again today. Yesterday also we interacted in 2 sessions. One was chaired where Dr. Chairman from the Department of Chemistry, Neera Raghav, she delivered the lecture, and for a while I talked about chemistry, our life, our future. Now we are coming to the fag end of this international conference, which is being held virtually on new trends in chemical research. While going through the proceedings of the conference, I found that the organizers have indeed put in a lot of efforts, and I see that there are around half a dozen speakers from abroad, from the countries like China, Poland, US, and so on and so forth. The lectures that have been delivered indeed address the research in chemistry with the new modern perspective. The inaugural session was, the chief guest was Dr. Ashok Kumar Bakshi, who has elaborated on the chemistry, teaching, research, pedagogy, and the requirements in the light of new education policy, whereby chemistry not only limited to the academic thing, but it can be extended to a skill-based science as well. The lecture by Dr. Ramesh Kataria emphasized on recent development in materials. See the diversity that the organizers have put in. It is not limited to chemistry, synthesis, synthetic chemistry only, the material sciences, the biosensors, and detection of virus diseases, economic effects thereof, and then the sensors for heavy metals like arsenic, multi-component assemblies, carbon quantum dots, several such topics have been addressed. And I was particularly impressed by the lecture which included microRNA mediated regulation of GI inflammation, gastrointestinal inflammation. Such are the topics, interdisciplinary topics, which a chemist now need to diversify, not limited to the traditional chemistry, but to the applied chemistry. So I have found that this conference has served its purpose, and a good number of participants participated in this. Of course, the times, the corona is not really gone. Had it been in-person conference, it would have added even more quantum to the content. But I'm happy that organizing a virtual conference of this magnitude, the organizers definitely deserve a lot of appreciation. The sponsors, the principal, the college faculty, the convener, organizing secretary, all deserve kudos from my side. So that's my remark on this. Anything else that we want to share? Dr. Deepa.
Yes, Professor.
That's my comment, because we need to...
Actually, your voice is volume is very low. I'm not able to hear.
Volume is...
Can you raise the volume slightly, please?
The volume is fine on my side.
Well, thank you, sir. Thank you so much for your blessing words. And it's a proud privilege to have you with us. And thank you so much for the valedictory address. And now I would like to call upon Dr. Sudhir Kumar for the conference report, please.
Thank you, Dr. Deepa, for inviting me. Good afternoon, everyone. I welcome Dr. Sudhir, Professor, Department of Chemistry, Chaudhry Charan Singh University, Chaudhry Charan Singh, Haryana Agriculture University, as chief guest of the valedictory session. This two-day international conference on new trends in chemical research, organized by Chemistry Department of Shahid Udham Singh Government College, Matak Majri, Indri, Karnal, was headed under the aegis of Department of Higher Education, Panchkula, Haryana. The objective of this conference was to bring together experts from academic institutions, industries, research organizations for sharing their knowledge and experience in the recent trends in chemical research. We had eminent speakers from China, Poland, Korea, Georgia, US, Pennsylvania, and USA. The conference program featured a wide variety of invited and distinguished lectures, along with oral and poster presentations of researchers from various fields of chemistry. Hundreds of attendees, paper presenters, and students have benefited in many ways from this conference. Nearly 200 scientific papers were presented, 6 international and 6 national invited speakers addressed the audience and shared their research experience. The first day of the conference started with the welcome address of Organizing Secretary, Dr. Sudhir Kumar. Dr. Gulab Singh, the convener of conference, gave the detailed information about the conference schedule. We had 5 technical sessions, which included invited talks and distinguished lectures of 12 eminent speakers from various countries. The chief guest of the conference, Dr. Ashok Kumar Bakshi, Vice Chancellor, PDM University, Bahadurgarh, Haryana, graced the occasion and addressed the audience about the issues of poor quality of research program and lack of research culture in India in the field of chemistry. He advocated for changes in the curriculum according to the need of the hour. In her keynote address, Dr. Professor Neera Raghav, Chairperson, Department of Chemistry, Kurukshetra University, Kurukshetra, deliberated on the exploration of research in the areas of education, food, health, energy, and tourism, and also sustainable development of the same. The first speaker of the technical session, Dr. Sudhir Kumar, enlightened the participant on the topic Chemistry, Our Life, Our Future. He stressed upon the relevance of chemistry in the fields of food, polymer, glass, cement, fermentation, chemoinformatics, and bioinformatics. Dr. Ramesh Kumar Kataria talked about recent developments of materials for the detection of heavy metal ions. He also talked about the sources of heavy metal ion contamination and developments of various sensors for mercury detection. Dr. Brij Mohan from College of Ocean Food and Biological Engineering, Jimmy University, China, shared his views on recent trends in development of biosensors for the detection of viruses and their effects on economy. He related his talk to the COVID-19 pandemic and development of various biosensors based on nanomaterials. Dr. Manish Kumar from National Food, Agri-Food and Biotechnology Institute, Mohali, talked about molybdenum-based metal organic frameworks for the development of ultra-sensitive and specific sensors for arsenic ions. He explained his work on the detection of arsenic ions from the food samples. Dr. Vijay Gupta from Poland talked on the topic entitled Multi-Component Assemblies, Design Perspective and Applications. He also shared his work on the poisonous metal detection. Dr. Vineet Kumar from Korea presented his findings on quantum dots and its applications for display devices and sensors. Dr. Sudhir Kumar, Dr. Rashmi Pundir, Dr. Raj Kamal, Dr. Ashwini Vihana, Dr. Kiran Singh, Dr. Sunil Dhul, Dr. Ramesh Ghangas have chaired their respective lecture sessions and gave their expert comments. The second day of the conference started with the distinguished lecture of Dr. Jayant Sindhu from Chaudhry Charan Singh, Haryana Agriculture University, Hisar. He deliberated on ESIPT, which means excited state intramolecular proton transfer. Dr. Manmeet Rawat from Penn State University, Pennsylvania, addressed upon the gastrointestinal inflammation, a complex biological response to an injury. He shared his work on microRNA mediated regulation of GI inflammation. Dr. Badri Prasad from Harvard Medical School shared his research findings based on influenza virus inhibition, multivalent polymeric system with spiky and concave neurostructures. Dr. Sushil Kumar Pandey deliberated on recent trends in pharmaceutical industry. He also highlighted the clinical research organizations and its future perspective related to the pharma industry. Dr. Virender Singh, in his distinguished lecture, discussed the exploration of chemoselectivity of Fumigian C. Dr. Sunil Dhul also talked about nitrogen-containing heterocyclic compounds with ring size of 5 members. Dr. Deepa Sharma also presented her work on carbon nanotubes. Dr. Praveen Jangra, Dr. Sushil Pandey, Dr. Kishan Kumar, Dr. Suresh Dua, and Dr. Deepa, along with Dr. Babita, chaired the sessions on day 2 and gave their critical comments. Nearly 550 researchers registered themselves for the conference and participated enthusiastically in the same. During the conference, on first day, we had our 4 parallel sessions, 4 poster presentations, and around 80 posters were presented by the various researchers. We also had 4 oral presentation sessions on day 2, where around 100 researchers presented their research work. Let me announce, we have selected 4 best posters and 4 best oral presenters, and that will be announced shortly, so please stay tuned for that. At the end, I would like to thank Dr. Satish Kumar Bhardwaj and Dr. Gulab Singh, convener of IC&TCR 2022, for giving me the opportunity to work as organizing secretary of the conference. That's all from my side. Best wishes to all the participants. Thank you all.
Well,
It's over to Dr. Deepa.
well, thank you, Suresh sir.
Much fun.
Thanks for presenting the report. And I would like to invite Dr. Gulab.
Yes, ma'am.
Over to you, please, for the vote of thanks.
Okay, ma'am. Thank you. सर म्यूट हो रखा है सर आपका, सॉरी। अब मेरी आवाज आ रही है आप सबको?
हाँ जी सर, ऑडिबल.
Good afternoon, everyone. Honorable Chief Guest, Professor Sudhir Kumar, Chairperson, Department of Chemistry, HAU. Participants, I feel honored to get this opportunity to conclude this 2 days online international conference entitled Recent Trends in Chemical Research. It is time to convey our gratitude to all who have extended their support to make this event successful. At the outset, on behalf of my institution, I would like to express my profound gratitude to Directorate of Higher Education, Haryana, and its officials for giving permission to conduct this online international conference and guiding the institution for this event. I would like to record our deep sense of obligation to our chief guest of inaugural session, Dr. Ashok Kumar Bakshi, Vice Chancellor, PDM University, Bahadurgarh, and chief guest of valedictory session, Dr. Sudhir Kumar, Chairperson, Department of Chemistry, HAU, for taking time from their busy schedule to be with us in this event. Sir, you both are really our source of motivation and energy. No doubt, organizing such type of international conference is a challenging task. It cannot be possible without a great preparation and support from every corner and blessings. Now my sincere thanks goes to each and every member of the International and National Advisory Board for their wise mentorship and encouragement. Respected, you all were always ready to listen us and immediately solve our problems whenever we approaches to you. Ladies and gentlemen, our word may not be capable to express our sense of gratitude to our worthy principal, Dr. Satish Kumar Bhardwaj, for his exceptional leadership, guidance, and support. Respected sir, you have given your valuable time in fixing many issues in this conference. Let me express my great gratitude to our keynote speaker, Dr. Neera Raghav, Chairperson, Department of Chemistry, Kurukshetra University, Kurukshetra, for her valuable talk on the theme of conference. I also extended my thanks to invited speakers, session chairs, and delegates who had accepted our invitation and given generously their time to make this conference successful. Your participation, I am sure, have given depth to the content and deliberation. thank you for being with us in this event. I must say that this conference could not be possible without the initiative and deliberation of organizing secretary of the conference, Dr. Sudhir Kumar. His day-night work and effective management is really commendable and appreciable, which played great role in the success of this conference. So I am really thankful to him for being driving force. I am also thankful to Dr. Deepa Sharma for coordinating this conference with so much sincerity and to Dr. S.B. Bhardwaj for managing the parallel session schedule of the conference in such a short time. Equally and on personal behalf, I am thankful to my colleagues for their dedicational support to make it such a great success. They have really worked hard selflessly and for the success of this event. I cannot mention each one by their name here. I hope that they will take it as a personal thank you. I also thank to admin staff and media for their active support. Last but not least, my heartfelt thanks goes to all the participants from overseas as well as within boundaries who have been joining us in this event organized by Department of Chemistry, Shahid Udham Singh, Government College Matak Mazri, Karnal. At the end, I bring sincerely apology to those who directly or indirectly help us and I forget. Yes, sir. Sir, namaskar. Sir.
Namaskar. Is it fine? I
Yes,
must
sir.
congratulate you that you coming from such a small institution, that to a degree college affiliated to some university, and you guys have put in so much efforts to organize a conference of this scale.
Thank you, sir.
I was particularly happy that you could associate people from abroad as well. And the contents, the titles that I have gone through are really nice. It means they give a new perspective to the chemistry research, and the younger generation should benefit from this. So my heartfelt appreciation to you all guys, whosoever are the organizers. I know Gulab, Suresh, and your principal particularly. So,
Thank you, sir.
well done, great. Keep it up.
Thank you, sir. Thank you.
So I take leave now.
सर ये जो सारी चीज ऑर्गेनाइज हुई हैं, ये सभी जो फ्रेंड्स हैं मेरे बाहर भी जितने हैं या यहाँ हैं या मेरे जो सीनियर्स हैं या मेरे जो गुरुजी हैं, आप जैसे लोग हैं, उन सब से देख के सीख के सर ये चीज ऑर्गेनाइज कर पाए.
होता तो इसी तरह से है, बट द थिंग इज कि आप लोगों ने इनिशिएटिव लिया, एफर्ट्स पुट इन किया है.
थैंक यू सर.
मतलब इसमें मेहनत लगती है, आई नो कितनी मेहनत लगती है, आप लोगों ने उसको किया है, तो मेरी तरफ से आप लोगों को जो है बहुत, हिंदी में बोलते हैं साधु हुआ.
थैंक यू सर.
ठीक है,
ओके सर. थैंक जी सर. थैंक यू.
ओके, ब्लेस यू ऑल.
थैंक यू सर. थैंक यू.
Congratulations.
भाई गुलाब सिंह, नमस्ते, धन्यवाद.
थैंक यू. थैंक यू.
Congratulations, Dr. Gulab Singh and Dr. Suresh Kumar, to host such a remarkable event at a short notice.
दे दिया उसने.
You both have really worked hard. I congratulate you.
सर मेरे पास व्हाट्सएप कर दीजिए सर, प्लीज. एक का सर, सिर्फ वन सर. और
Sorry, sir is busy on call, so I will my comments after his conversation. Gulab sir, I was making congratulations to you and Dr. Suresh sir to host such a remarkable event at a short notice. You both have really worked hard for this conference. And I have seen both of you, I have seen your dedication towards the conference work during this period, and surely it's a work of, it's a result of it. From the very beginning of the conference to the end, everything was executed finely and professionally.
whether it was the time management or the selection of the session chairs or speakers or the research content that has to be presented at this platform. I hope the content shared by the young scientists from all over the world at this platform will take the research to the new heights in near future. One of the most important things that I have seen in you, you both were very faithful to your organizing team also. Most importantly, I would like to say that you have handled every occurred situation that occurred during this period very patiently. I congratulate you for this also.
Thank you, sir.
I again thank you, sir, again on side of the Department of Mathematics, and hoping to see you again to organize such kind of international conference in your future also. Thank you very much, sir, and congratulations to you and your organizing team. Thank you.
थैंक यू सर, थैंक यू. और मेरी ऑर्गेनाइजिंग टीम आप सभी हैं, तभी ये चीज हो पाई है, और ये कोई अकेला नहीं कर सकता है, सबने मिलके जो है किया है. और इतने जगह से दोस्तों ने सहयोग किया है, इतने सारे साथी यहाँ मिले हैं, जुड़े हैं, हर तरह से उन्होंने जिस तरीके से सहयोग किया है वो एक वास्तव में जो है मेरे लिए बहुत खुशी की बात है कि मेरे संपर्क में इतने सारे चाहने वाले जो हैं, इतने सारे दोस्त, इतने सारे जानकार हैं जो मेरे रिक्वेस्ट को, मेरे इनविटेशन को इतनी आसानी से एक्सेप्ट कर लेते हैं, और मेरे एक बार कहने से जो है ये चीज़ ऑर्गेनाइज हो जाती है. वैसे इस सारी ऑर्गेनाइजिंग में जो है मेन जो सेंटर पॉइंट रहा है वो डॉक्टर सुरेश रहे हैं, क्योंकि इनिशिएटिव भी उन्होंने ही लिया था. ये उन्हीं का ही डिसीजन था कि ये ऑर्गेनाइज किया जाए, और उन्होंने शुरुआत की थी और वो इसको यहाँ तक लेके आए. तो इसके पीछे जो सबसे ज़्यादा जो मेहनत लगी हुई है वो डॉक्टर सुरेश की लगी हुई है. और एक्चुअल में ये कॉन्फ्रेंस जो है मैं कहना चाहूँगा कि उन्हीं के द्वारा ऑर्गेनाइज की गई है. मेरा उनके साथ सहयोग रहा है, मैं इतना ही कह सकता हूँ, लेकिन मैंने ऑर्गेनाइज की है, मैं ये नहीं कह सकता. थैंक यू टू ऑल. आप सब इतने जगह से जुड़े, आप लोगों ने बहुत ज़्यादा पार्टिसिपेशन इसमें शो किया. लगभग 500 के आसपास जो है पार्टिसिपेंट यहाँ जुड़े, यूट्यूब के थ्रू और गूगल मीट के थ्रू इतने सारे लोग हमारे साथ जुड़े. हम उन सब का धन्यवाद करते हैं. थैंक यू टू ऑल.
I would like to say something. Dr. Gulab Singh, it's a team effort. It's not a one-man job. So the congratulations should be for whole team, not for one person. One person cannot organize a conference, and it will be by everyone. Each and every person have contributed from a lot of parts in terms of technical sessions, in terms of technical assistance, in terms of organizing. So I congratulate all the team, and thanks to all.
भाई गुलाब सिंह.
यस.
Yes, sir. Jaiswal.
जयस्वाल.
Congratulations, Dr. Glass and Dr. Suresh.
थैंक यू मैम. डॉक्टर नरेश, आपका बहुत बहुत धन्यवाद कि पूरा जो डिजिटल मीडिया है वो आपने संभाल रखा था. पूरी कॉन्फ्रेंस आपके दम पे चल रही थी. थैंक यू. आप इस पीछे खड़े रहे, दिखे नहीं, लेकिन पूरी कॉन्फ्रेंस चल आपके दम पे रही थी. चला चाहे कोई रहा था, लेकिन चल आपके दम पे रही थी. तो आपका बहुत बहुत धन्यवाद सर. अब इसको कंक्लूड कर लेते हैं सर। थैंक यू ऑल। नरेश सर, अभी फीडबैक लिंक जो है मैं शेयर कर रहा हूं यहाँ पर भी और ग्रुप में भी, ठीक है? तो सभी जो है फीडबैक लिंक फिलअप जरूर करेंगे और बेस्ट प्रेजेंटर जितने भी रहेंगे हर एक सेशन के वो हम ग्रुप में शेयर कर देंगे उनका रिजल्ट, क्योंकि सेशन जो है अभी तक चल रहे हैं बहुत लेट तक, क्योंकि बहुत ज्यादा पार्टिसिपेंट हैं। तो फाइनल रिजल्ट जो है वो हम ग्रुप में शेयर करेंगे। थैंक यू ऑल ऑफ यू।
थैंक यू सर।
ओके नरेश सर।